Let's take a look at solving systems of inequalities. So when we solve systems of inequalities by graphing, we use three main steps. We want to solve each inequality for y, we want to graph both of them on the same graph, and then we want to look to see where the two shaded regions overlap. Those are our three big steps that we need to take. So for the first symbol we come across, we have less than. That symbol means we need to use a dashed line when we graph it because it's not equal to, it's just less than, but not equal to. And then we shade below the line because it's all the points that are less than that line. For less than or equal to, it's similar because it's going to be shaded below because it's still less than, but now it's equal to, so we need to make our line solid. So then we have greater than and greater than or equal to. So when they're greater than, we shade above the line, but then greater than is not equal to because you don't have that extra line underneath the symbol. So it's going to, again, be a dashed line on the graph. And then the last one is greater than or equal to. So think greater than means we need to still shade above the line. But then it's got that or equal to bar, so it needs to be a solid line. We call it a boundary line sometimes for our shaded area. So let's look at a couple of examples. These say solve the system of inequalities by graphing. We're given y is less than x plus 2 and negative 2x minus 3y is less than or equal to 9. So I can see that the first one is already got y by itself, but the second one needs a little work. So let's start with that. We have negative 2x minus 3y is less than or equal to 9. So let's start by adding 2x because it was subtracting, and we always need to do the inverse operation to move it over. So then that will help us cancel out the negative 2x. And we bring down negative 3y is less than or equal to 2x plus 9. And then we need to get rid of the negative 3. So negative 3 times y means they're multiplying. And I need to do the inverse operation and divide by negative 3. So then I get y, and I divided by a negative. So I need to switch the direction of my inequality. And so instead of less than or equal to, it's going to become greater than or equal to. And then I have negative 2/3. So I'll just leave that there as my slope. And then plus 9 divided by negative 3, which will be a y-intercept of negative 3. So now I'm ready to graph these two now that they're both with y by itself. So in the first equation, I'm going to do this one in blue. So y is less than x plus 2. Start with your y-intercept at 2, and then use your slope of 1. So that means we go rise 1 and run 1, or go to the right. So 1 up and 1 over. And then you want to pay attention to your symbol like we talked about. It's less than, but not equal to this line. So I've got some good points. Now let's make it into a dashed line that connects those dots. And then I can draw a few going the other way as well. And then I want to think of the shading. It's less than, so that makes sense that less than would be shaded below the line. So all the values below that line would be included. Now let's use another color to graph the other line. And that way it'll be easy to see where they come together. So I'm going to use red. And let's graph y is greater than or equal to negative 2/3 x minus 3. So I'm going to start with my y-intercept of negative 3. And then I'm going to use my slope of negative 2/3 to go down 2 and right 3. And I'm going to go down 2, right 3. I'm going to go up 2 and left 3 because that's also a negative move. And then up 2, left 3. Whenever you have a negative slope, you only want to do one negative move. You only want to do down or left, but not both, because then you end up making it into really a positive slope, because two negatives make a positive. Let me put that in the right spot. So I need to go up 2, left 3. So now you want to think of your line. You have a greater than or equal to sign. So I need to graph a solid line in between those points. And I need to shade above the line because it was greater than. So greater than means all the points above that line. So up here above that line. And then my solution set is going to be all the points where those two colors come together. So the red and the blue will shade as purple area here. So any point in this area that's purple would be a solution to my system of inequalities. So down here at the bottom, it says a possible solution. So let's name a possible solution. For instance, 2, 1 is a great example of a possible solution. It's definitely in the middle of that shaded area. A point that is not a solution, a good point to look at would be like our y-intercept right here at 2. So 0, 2 is not a solution. It looks hopeful because it's on the boundary line of this blue equation or inequality, but it's a dashed line, so it's not included. Another example would be, let's say -2, +2. And let's just put another possible solution that is a solution. Like 2, -2 would be another good one that is a solution to our system because it's in that purple shaded area. So let's do another one like this one. So first we need to make sure we get y by itself. So these two both need some work. We have -x minus y is greater than or equal to 4. So let's add the x since it's being subtracted and bring down -y is greater than or equal to x plus 4. And then we need to get rid of the understood -1. So let's divide by -1. And then bring down y, but we divided by a negative. So it's going to change the direction of the sign. It was greater than or equal to, but now it'll be less than or equal to -x minus 4. So that's it for that one. Now let's look over here at the other one on the right. So we have -2x plus 3y is greater than -12. So let's add 2x to get rid of the -2x because that's the inverse of subtracting is to add. And we can bring down 3y is greater than 2x minus 12. And then we can divide to get rid of the 3 because the 3 times y means they're multiplying. And we need to always do the inverse and say y is greater than 2/3 x. We don't have to change the sign this time because we divided by a +3. So we'll leave it as a greater than sign. And then -12 divided by 3 is -4. So now that we have y by itself for both, I'm going to graph the first one in blue and I'm going to graph the second one in red again just to keep that same color scheme. So let's start with our blue one. We have a y-intercept at -4. So go to -4 and plot that point. And then we have a slope of -1 over 1. So we go down 1, right 1, down 1, right 1. And we can also go up 1, left 1 a couple times because that's also going to stay in line with our -1 slope. And we have a less than or equal to sign. So that means we need to have a solid line because it's equal to. And we have a less than sign. So we need to make sure that we shade below the line for that one. And then for the next one, we have y is greater than 2/3 x minus 4. So let's go to also to -4 and plot. Let me get my pen. -4. And we need to plot a slope of 2/3. So let's go up to right 3, up to right 3. And we can go down 2 and left 3 as well. And then we just have a greater than sign. So let's make a nice dashed boundary line because it's not equal to, but just greater than. And then we need to shade above the line because it's greater than. And then you want to pay close attention to where your shading comes together. So over here in this region is where our solution would be. So to pick out a solution, we want to pick out one that's in that shaded area or on a solid line that's our boundary line. So for a good example, we could say -6, -3 is definitely a solution right there. But we can also say -3, -1 because that's sitting on a boundary line that is solid. A solution or excuse me, a point that is not a solution. So let's pick out, like, we could say 1, 4 is not a solution. That's over here in the region that's not shaded in blue and in red. For instance, like 6, -2 is definitely outside all of the shaded regions. So that's definitely not a solution. And we can certainly name more points that are inside and outside of our solution set. Those are just a few examples. So that is it for graphing systems of inequalities.